I'd like to talk about using Ethernet. Ethernet is a common technology for local networks. The goal of Ethernet is to send data from one computer to another. The Ethernet protocol is designed to solve the problem of concurrent messaging. In other words, if two computers are trying to talk at the same time, Ethernet will prevent them from interrupting each other. Ethernet is a link layer protocol. In other words, it is designed to link different machines together. Ethernet is the most common link layer protocol on local area networks, sometimes called a LAN. Another link layer protocol we see commonly used today on much larger networks is called Data over Cable Service Interface Specification, sometimes abbreviated as DOCSIS or DOCSIS. This is a protocol designed specifically for the cable companies. So if you have your internet service through a cable modem, the communication from the cable company to your cable modem is probably DOCSIS, but your cable modem probably converts that into an Ethernet signal, and inside of your home or inside of your office, it's probably running Ethernet because that is the most common on local networks. In order for Ethernet to send data from one computer to another computer, it needs a way to uniquely identify each machine. That unique identification is called an address. And specifically with Ethernet, it's called a Media Access Control address, most commonly abbreviated as a MAC address. A MAC address is a 48-bit binary number. So when one computer talks to another computer, they exchange this sequence of 48 binary numbers. But MAC addresses can be converted to a different format to make them more easy for human beings to read. And typically we see MAC addresses as a 12-digit number with digits placed into groups of 2 with a dash between each group. The digits include the numbers 0 through 9 and also the letters A through F. When two devices on the network try to use the same resource simultaneously, we call that a collision. For example, if two computers are trying to send out information at exactly the same time, that is a collision. The Ethernet protocol automatically detects collisions and does something to fix them. What it does, it asks both devices to stop sending information. It asks both of them to wait a few milliseconds and try again. But it will ask both of them to use a different amount of time. So for example, one device might be asked to wait 10 milliseconds. The other device is asked to wait 30 milliseconds. And therefore, when they restart, they won't be restarting at the same time. So Ethernet has the ability to detect collisions and fix the collisions. When two or more devices share a resource, we call this a collision domain because there is the potential for a collision. If any of those devices that share one of those resources tries to send out information at the same time, we say those two machines are in the same collision domain. If two devices don't share any resources at all, and therefore they could both send data at the same time, we say those two devices are in different collision domains. If we have 8 computers connected to a single hub, all 8 of those computers are in the same collision domain. And if any 2 of the computers send information at the same time, this will cause a collision. A small number of collisions is not a significant problem. Ethernet will automatically detect the collisions and fix them. However, if our network starts to have a large amount of collisions, we could see a performance degradation because every time a collision occurs, both sides have to wait. So there is a small amount of time wasted by every collision. So one of our goals in network design is often to reduce the number of collisions. And we'll see how to do that in some of the upcoming sections.